And this is going to be like your homework tonight. Is going to be making basic sketches. In your homework tonight, when it says graph, you don't need to do it on graph paper. Even though, I'm showing you on a graph because I want everything to be just nice and perfect. But in your homework tonight, you don't have to do it on graph paper. You can just make a basic sketch like this. And this will be enough because we're not plotting a bunch of points. We're just plotting only one point. So that'll be fine. So, what is the y-intercept of this function? The y-intercept is -2 because that's my, where's my cursor? Oh, pen's upside down. -2 right there. That's the a value. That's my y-intercept. So right there, that tells me to go to -2 and put a dot because that's going to be the y-intercept of my graph. Now, this fits the model of the parent function. Nothing's being added on or subtracted, so this is the parent function. What did I tell you the asymptote would always be for the parent function? It's always going to be the x-axis. So for right now, the x-axis is the asymptote. So I want you to graph the asymptote as a dotted line. So everybody just put a dotted line as best you can right on the x-axis. Okay? That's the asymptote. So, now, there are two possibilities. Either my graph is going to be going, let's see, either my graph is going to be going towards the asymptote, getting closer and closer and closer like this, okay? That's one possibility. Or my graph is going to be going further and further away from the asymptote as I go from left to right, like this. So this is where the b value comes in. So I want you to tell me, is it going to be the pink graph or the green graph based on this b value? I'm hearing different answers. Let's see. Give me a thumbs up if you think it's going to be the pink one. Give me a thumbs down if you think it's going to be the green one. Thumbs up pink, thumbs down green. Let me see where we are so far. Thumbs up pink, thumbs down green. Okay, put your hands down. Most people are saying thumbs up pink, and that is correct. It's going to be the pink graph. Why? The b value is greater than 1. When the b value is greater than 1, we're going to be getting further and further away from the asymptote whenever the value is greater than 1. It would be the green one if this were just 0.5, say, something less than 1. So it's definitely going to be the pink one, so I'm just going to erase the other one. Okay? So your graph should look something like that. Any questions? That's really all there is to it. That's what I want to see on your homework tonight, just something basic like this. Yeah, that was it. We're just graphing. That was it for now. Basics. This day is about basic sketches, just the general idea. We'll get into more detail on Monday. Look at this graph. Let's see. Kelvin, can you tell me what the asymptote is going to be, that dotted line that I'm going to approach? The x-axis. There's nothing added on or subtracted. The x-axis is going to be the asymptote. So draw your dotted line on the x-axis as best you can. Now, Jesus, what's the y-intercept going to be? The y-intercept is going to be 3. So everybody put a dot at 3. That's my y-intercept. Okay? Now, these are the two possibilities. It's either going to be the red or it's going to be the blue. Okay? It's just a matter of choosing between these. And this is where the b value comes in. Give me a thumbs up if it's going to be red. Give me a thumbs down if it's going to be blue. Thumbs up red, thumbs down blue. Okay? Okay, put your hands down. Most people were saying thumbs down, and that is correct. Okay, it's going to be the blue this time. Why will it be the blue?
It's less than 1.
2/5 is less than 1. 2/5 is less than 1. If the b value is less than 1, that means it's going to get smaller and smaller, closer and closer to the x-axis. So you would draw it as the blue one. That's it. Any questions on number 2? Okay. Look at number 3. This one's slightly tricky for one reason. Can you tell me what the y-intercept is going to be?
0.
The y-intercept is going to be 1. Okay? I think I could hear you seeing that we're missing that a value. You couldn't see it. So you were thinking, well, either it was going to be 0 or 1. In this case, an invisible number would have to be a 1. Think about it. If it were a 0, that would wipe out the entire equation, and I'd have nothing to graph. So it must be a 1. It must be a 1. So the y-intercept would be 1. Margaret, what's the asymptote line going to be? Yeah, the x-axis is the asymptote line. Okay? Now, is it going to be the red or the blue? Will it be the red? Or will it be the blue? Okay, thumbs up red, thumbs down blue, real quick. Thumbs up red, thumbs down for blue. Red or blue? Okay, put your hands down. Most people are saying thumbs up red. And that is correct. Why? 4 over 3. Notice how we have the bigger number in the top? 4 over 3 is bigger than 1. Even though it's a fraction, it's bigger than 1. Therefore, it should be an increasing graph that's getting further and further away from the x-axis. So the red one is the one we want. So I'm just going to erase the other one. Okay? So that would be the correct graph. Any questions? Okay. Number 4. Let's see. Margaret, what's the asymptote going to be? Still the x-axis. Everybody draw a dotted line on the x-axis as best you can. Margaret, what's the y-intercept going to be? Negative 1.5. So go down 1.5 squares. So your y-intercept will be there. Okay? All that's left is the curve. Okay? Is it going to be red or blue? Okay? Thumbs up red, thumbs down blue. Which one is it going to be? Thumbs up red, thumbs down blue. See everybody's thumbs real quick. Okay, put your hands down. Most people are saying thumbs down blue. And that is correct. It'll be blue. Why? Right. 0.27 is less than 1. Whenever it's less than 1, the graph should be getting closer and closer and closer to 0. Closer to the x-axis. So that's why it's the blue one. Does anyone, who does not understand? Raise your hand if you don't see it. You don't get what? Okay, this might help. Okay. When kids get confused, it's usually because they're not strictly thinking left to right. Okay? So think of the way you read a book. Alright? So when you look at this graph, I want you to strictly read it from this side to this side. So when you're looking at the red line, am I getting closer to the x-axis or further away? Further away. When I'm reading the blue line, am I getting closer or further away? I'm getting closer, okay? If that b value is bigger than 1, I should get further away. Okay? If that b value is less than 1, I should get closer. So as long as you're reading it from left to right. So you look at that 0.7, you think, oh, that's less than 1, closer. Then just make sure you're reading from left to right, and you'll think, oh, okay, it's going to be that blue one, because it's going to get closer and closer. Okay? Of course, on the quiz, you won't have them to choose from. You're going to have to draw it yourself, but I think you'll still get the idea. Okay? Number 5. Aha! This is not the parent function anymore. It has this plus 3 on the end. Based on what we learned a long time ago, what effect does it have on a graph when you add 3 on the end like that? It shifts everything up 3. Adding a number on the end like that moves everything up 3. So, instead of being the x-axis, what will the new asymptote be? It'll be up 3, and I like what Anoop was saying. Everybody listen to what Anoop was saying, okay? Anoop is naming this line, and you're going to have to do this. So you guys, please remember that the equation of a horizontal line is always y equals a number. So this horizontal line is the line y equals 3. So on a quiz, I'll be asking you, what's the asymptote? You'll say, oh, the asymptote, y equals 3. You'll say the little equation. Okay? So there's my new asymptote. Now, I have to be careful with my y-intercept. If I didn't have this 3 on there, if there was no plus 3, what would the y-intercept be? It would be 4. It would be 4. Okay? Now, everything's been shifted up, though. So when you count your y-intercept, you better count it from the asymptote. So it's going to be up 4 still, but up 4 from the asymptote. So I didn't actually leave enough space for this. It's going to be off the graph a little bit. So your y-intercept should be 4 up from the asymptote. Okay? Margaret, am I going to be going away from the asymptote like this, or am I going to be going towards the asymptote like this? Away. 2 is bigger than 1, so I should be going away like this. So when you draw your graph, it should be doing like this. Okay? Number 6. Number 6. Miss Street, tell me where the asymptote's going to be.
It would be the 3 or the 4, right?
No, the asymptote, the graph, what kind of shift is happening? Is it going up or down?
Down.
It's going down how many?
2.
It's going down 2. Normally the x-axis was that horizontal asymptote, but since everything is going to be shifted down 2, the new asymptote is going to be shifted down 2. So everyone should make your dotted line down here. How will I name this line? I will name this line y equals negative 2. Where's my y-intercept going to be? It's going to be right here. The invisible 1 in front tells us about the y-intercept. It's up 1 from the asymptote. Up 1 from the asymptote. It'll be right there. Denzel, am I going away from the asymptote or towards the asymptote? Is this bigger than 1 or less than 1? Right, but it's the b value that tells us towards or away. Okay. Since this is less than 1, we're going to be going towards the asymptote. Whoops, I messed mine up a little bit. So your graph should be looking something like that. Okay? Time to pack up. Note that your homework is in the textbook. There are going to be little graphs like these. So you just make your little sketches.